So,
Are all those graphs gonna be on the quiz? Is that gonna be?
yeah, there's one.
Oh, okay. I thought it was gonna look like I was gonna cry.
Oh no, there's just one. Excuse me. Hi. Hi. He could not be rude. That'd be awesome. Thanks. Okay, so um first I'm going to find out the quadrant. This says cosine is a positive number, so I'm going to put a plus in the x spot. And this says tan is less than 0. So if tan is negative, that means that y has to be negative. Because tan is y over x. So one of them has to be negative, but not both. So what quadrant is this? So close. 4. 4. Okay, you're gonna need to know that, like how to figure out the quadrants. The good news is when I walked around, I saw a lot of triangles in quadrant 4, so that's good. Okay, and then cosine is 1/2. Sine is what we're solving for. Hypotenuse is what? Okay. 1/2 squared plus y squared equals 1 squared. By the way, did anybody finish this problem and feel silly? Yeah. Okay, just checking. Because technically you should finish if you know what you're doing in this class, you should finish this problem and feel silly. If you felt silly at the end of this problem, then you know what you're doing. And you're like, if I didn't feel silly yet, Mrs. Talbot, it's okay. Okay, 1/4 plus y squared equals 4/4. Everybody okay with my jump from 1 squared to 4/4? Hello? No? Okay, I'll just write it out. Okay, hold on. We're not there yet. We're not there yet. We're not there yet. We're not there. 1 second, 1 second, 1 second, 1 second. Actually, well, hold on. This problem doesn't require all this work, but it's okay. Okay, so far, so good, right? Okay, square root. So I have y equals plus or minus square root of 3 over 2. And then you're supposed to realize, oh, this is a unit circle one because it's a 30, 60, 90 because you have a 1/2 and a root 3 over 2. If you had noticed the 1/2, you could have just skipped to the root 3 over 2 here without doing any work, but that's okay. Okay, now in this problem, do we want the positive or the negative? Negative, great job. So sine theta is negative root 3 over 2. Okay, and then I'm going to do tan. Tan is opposite over adjacent or sine over cosine or y over x, however you want to look at it. Negative root 3 over 2 over 1/2, which is negative root 3. You guys see where my negative root 3 came from? I canceled out the 2's and then the 1 just went away. So you can do this if you want. So it's negative root 3 over 1.
Oh.
It's early. It's early. Okay. Move down to number 4, please. Okay. So the goal of this is to be practicing negative rotation.
where you draw, I know like where you draw the line for the triangle, but like, you know how you connect the triangle to make the full triangle? Like say, I'm bad.
It matters. Yes, you need to draw to the x-axis every time. Yeah, every time. Um, okay, so 205 is here-ish. You think? Ish? Okay, and so I'm gonna do the reference angle is 205 minus 180, which is 25. Okay, now I'm just going to note this is 0. This is negative 270, but it's positive 90 also. This is negative 180, but it's positive 180 also. This is negative 90, but it's positive 270 also. This is 360. It's also negative 360. Nice. Okay, so if this is 25, then this is 25. So quadrant 1 is 25. Okay, quadrant 2 is going to be 155. Okay. Ooh, that hurt my brain a lot. Quadrant 3 is going to be positive 205. That didn't hurt as bad. And quadrant 4 is 335. Yeah. Thanks. Now, yesterday we did not do the whole problem. Did anyone notice? Anyone? It says, yeah, we forgot to use the terminal, so we're going to fix that right now. Okay, so a bunch of people did coterminal wrong on that multiple choice problem on the test. So I just want to make sure that you are looking at the coterminal from the original problem, not one of these other ones that we wrote down or the reference angle. You're looking at the original. So positive coterminal is negative 110 plus 360, which is 250. And look, see how we labeled it? You could see the coterminal now. Like that's the whole point of coterminal. Negative coterminal, negative 110 minus 360, negative 470. Okay, now I get to put away yesterday's pen because it had to match the pen because, that's how I have to live. Okay, so positive coterminal here, negative 205 plus 360. But I don't really need to do that. I already did it. It's right here. Negative coterminal, negative 205 minus 360, which is negative 565. Is it negative 565? Okay. Now, can you guys please find the quiz review in your packet? It's quiz review. Quiz review. Is there anything you'd like to ask about in the quiz review? Yes, Connor. I'm not doing 3 through 6, so you can definitely not gonna do that, but I will do one of them. So pick wisely. Just one. Just pick wisely. Does anyone have one that they would like me to do in the 3 through 6 range? Anyone else that we could just kill two birds with one stone? Okay, anyone else? 3? They're all the same level of difficulty in my mind. 5, 5. We have 5. We have a vote for 5, going to 5. Okay. A. Okay. -2. 1/2. 2 pi over 1/2 is 4 pi. How many boxes is 4 pi on here? Great. Just made myself a little ruler. Okay. Well, honey, 8 boxes. You see where I got the 8 boxes from? Look at my little line on the x-axis. So I went from the origin to 4 pi, and then I just made a little like ruler and then counted how many boxes that was. Okay, please stop talking. H is negative pi. K is -4. Okay, so we start with K, and that's -4. So we dash there. And then the amplitude is 2, so we go 2 on either side of that. I just measured how long 4 pi was for the period. Okay, Connor, are you okay with the -4 and the amplitude of 2? Okay, now I need to find the locator point, which for sine is HK. What's the locator point for cosine? HK plus A. Okay, so locator point is negative pi, -4, negative pi, -4. I actually put that in the wrong spot, I think. Negative pi, -4. You see where the negative pi, -4 went, right? Okay, now I'm going to use that little ruler I made up here. So I'm going to count 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so negative sign looks like this. And I need to fit this in here. Connor. Okay, negative sign looks like this. And I need to fit this here. So this is this dot. Yeah. And this is this dot. So this is the start dot and the end dot. So I like to do the middle dot next. and then I do the first dot, and then I do the last dot. And I'm gonna leave it looking like that. I'm not gonna make the rest of the waves for now because I really want you to see that negative sign shape.
So the middle dot is just
In between the two, yeah. So 4 boxes on either side.
okay. Oh,
Okay, so yes, do you have a question? You do have a question? Okay. Oh, yeah, hold on. Before I move on from this, so what are the things that you need to memorize? You need to know where A, B, P, H, and K are.
mhm.
You need to know that P is 2 pi over B. You need to know the locator point, either HK or H comma K plus A, and you need to know the general shapes. And that's what you need to know.
I don't have, I can't put it on the graph, man.
Okay, now back to this. Okay. Shanice and Mike are planning trips to 13 countries this year. There are 15 countries they would like to visit. They are deciding which countries to skip. Okay, all of the countries they're treating the same, like the same level of importance to them. Does that make sense? Okay, so this is a combination. And there are 15 total countries, and they are selecting 13 of them to visit. And what is the combination formula? 15. Yep.
15 minus 2.
13.
Minus 13. Yeah, 13. That's the major point.
Correct. Yes, great job. Oh my gosh. Yes, honey. There's a combination formula is different from the permutation formula. So do you mean like, where does it come from? Like, why is it there? It's because you have to divide out all of the repeats. So as I was saying with my pens, when you're talking about a combination, these 3 things are all the same. So this considered to be the same thing as this, which is the same thing as this. So you need to divide out all of the repeats of that when you're doing a combination. So when there's a permutation, they're all different things, but when they're combinations, they're all the same. Okay, so does it make sense to you guys that the top would be just 15 times 14?
Yeah.
Okay, do you see where I got that from? So the 15 factorial and the 13 factorial are going to cancel out everything 13 and below. And the only things that would be left would be 15 and 14. So this is 15 and everything down and 13 and everything down. Okay, now what would be left on the bottom? 2 times what? Okay, so now how do we do this with no calculator? So cancel this out, make that 7. 15 times 7 is 70 plus 35, which is 105. You guys see my calculator, like how I did this? I did 7 times 10 and then 7 times 5, like distributive property.
Never mind.
Are you sure?
35 came from the 5.
Yeah, so I did 7 times 10 and then 7 times 5, just like distributive property. Yeah. If you know how to do 15 times 7 a different way, by all means, that's my lazy way of doing it. Okay, next one. Yes.
That's like every elementary teacher. No, I hated that. I lose country, I didn't say.
Okay, let's just go over 8 while we're here. So captain and co-captain are different from each other, as I have said repeatedly, even though I don't know anything about sports. So this is 15 permutation 2. Does that make sense? Hello? Yeah, okay. So 15 factorial over 15 minus 2 factorial. Okay, and then the 13 and down is going to cancel out, so it's just 15 times 14. How do you want to do 15 times 14 with no calculator? Let's see. What?
He was right. Ah.
Okay. Do you guys see my little area model I made? You can always go for that. Okay. Um, can you guys get out your notebooks, please? And thank you. Okay. Okay. Why am I thinking my own? Okay, now before we start with the notebook, I have failed you because I've had a joke every day, but I have run out of time. So I'm going to show you 3 jokes because I have to do it now. Otherwise, it's just not going to happen. Okay, so this is back to Friday. We did the permutations and combinations notes, which I made in rainbow because of my pens. And we started 10-1 to 10-6. And here was my joke. There is a protest sign and a protest cosign. Oh, good. It's good stuff. It's good stuff. Okay. Like sign spelled a different way, honey. Like SIGN sign. It's just a joke. It's just supposed to be funny. Okay. Then this is from yesterday. So we finished 10-1 to 10-6. And the homework was the quiz run review, and it says my girlfriend is the square root of negative 100. She's perfect 10, but purely imaginary. Okay. And here's today's. We're doing 21 to 24, which is more of the Gauss formula. And here's the homework 31, 33, 34, 36. It says 7-year-old me seeing an X in math, 17-year-old me seeing a number.
Nah, that's true. That's true.
Okay, now you guys can set up your notebooks.
Like going left. Take the photos.
Mr. Talbot said his worst mistake of 2024 was buying me this calendar because of it gave me ideas for all the ones I wanted to buy. Yeah, but he actually doesn't care. He's great. He's much happier when they come live here in the classroom.
My dad had a lot in the household for a little bit. Not He had like 18 different sushi.
Bless his heart, bless his heart. I liked all of those jokes.
Yeah, good run.
I had to like show them to you because I was like, man, these are actually decent ones. All right, guys, here we go for number 21. We're trying to calculate the sum of an arithmetic series. Antonio draws a graph of the terms. He notices he could take the rectangles representing the second half of the terms, rotate them, and they will fit perfectly with the rectangles of the first half of the terms. So he did his Tetris a little different. He didn't make two of them. He just flipped the second half onto the first half. Use this graph to answer the question below. How can Antonio be sure that the result of stacking the terms this way will be a rectangle?
I mean, if you're looking at it, it looks like it's making the rectangle. You know what
Right.
I'm on?
So what I was gonna say is because they grow by the same amount each time, that the height of the bars is going to be changing constantly, so it should always fit.
Mm, mm.
Okay, so okay, B. What is the sum of Antonio's series? How do you know? Okay, so we're gonna do our formula from yesterday. I want you guys to look at the original before he flipped it. So how many bars were there before he flipped it? 16 before he flipped it. Okay, so we're gonna write our formula. Sum equals n over 2. First, no, 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 no. First term plus last term. Okay, so sum equals 16 over 2, right? We had 8. Okay. Okay, now before he flipped it, what was the height of the first bar? 2. And what is the height of the last bar?
Hour. Well,
It's 11. It's 11. It's hard to see. I'll just tell you. Oh, it was me. I'll explain
I
later.
know that.
Which terms? Okay, okay, hold on. Write out Antonio's series. We already computed this up. I think I did too much. Okay, so if we want to write the series out, let's actually see if we can figure out what it would be. So it starts at 2, correct? And then there's some stuff and some stuff and some more stuff. And then it goes out to 11 is last. And we know this is spot 1, spot 2, spot 3, and this is spot 18. Does that make sense? We good? Okay, so what I'm going to do over here is I'm going to figure out how to get the growth. And when we're missing something, what did I always say to do? Go to the equation. Okay, and in this one, we have to use it in the terms of the first term because we don't know the growth. So I'm going to write T of n equals D n minus 1 plus T1. This is the general equation for when you're working with the first term and not term 0. T of n in this case is 11. D is what we're solving for. We want to know the growth. N is 18. And the first term is 2. Mm, it's 16. Thanks. You're on fire over there. Confuzzled?
Yeah, that's the exact word I was gonna say.
That's crazy. Okay. Okay, so I got a lot of stuff here. I found D is 0.6. I used that to fill in the ones that I was not lazy enough to write. And then I rewrote the equation with D and then first term. My favorite what? That's so hard. I think Benihana fried rice.
That's not a crazy thing. It's not that good. It is good.
My family, we have this thing where it's just gonna sound terrible, but like, let's just say that you got convicted for something terrible and you were on death row. Like, what would be your death row meal request? I think it would be Benihana for me. Like the whole steak and yeah, yeah.
I just want to
True, true.
say, That's only in a day. You gain weight like throughout that. Like, say you're like 110, can you go from 110 to like 160 in like one day just from eating the whole entire day?
I don't know. I'm trying to always go in the opposite direction of that, so I wouldn't know. And my stepson, he's you guys his age, he's 17, and he got a cold and lost 10 pounds. Like, I don't understand how that
It's the blend. When you're spending all the time out, it has to be.
literally went to the doctor and they gave him an antibiotic, and then he went back to the doctor and he lost 10 pounds.
I want
Like,
to
how?
Yeah.
What? I just turned this so that I gained 10 pounds. Okay, anyway. All right, let's do this so we can be done. Arithmetic sequences. They are patterns with commas. Very specifically, patterns with commas. What? Oh, commas. Got it. Understood. Repeated addition of a common difference D. So the growth in these is the letter D. And we're going to do the equation twice. We're going to do it with term 0 and term 1. Most of the time you can choose. Sometimes you can't. As you've seen, we have no ability to get term 0, so we have to use the term 1 equation. Term 0 is T of n equals D n plus T0. And if you want to do it in term 1, in terms of term 1, T of n equals D n minus 1 plus T1. Okay. Arithmetic series are patterns with plus signs. That's the word sign that I was trying to make the joke about earlier. Okay, and there's a formula for that. It is Gauss's formula, sum equals n over 2 first term plus last term. Okay, so we have an example here. We're going to find the equation. We're going to find it both ways. So we're going to find it in terms of term 0 and term 1. When you guys start doing the worksheets, like the mid-chapter worksheets or whatever, I'm going to ask you for both, just to make sure you can do both. But first, I need to figure out what the growth is, and it looks like it's 7. And I need to figure out what term 0 would be. 4. Okay, so equation for term 0 would be T of n equals 7n plus 4. And then first term would be T of n equals 7n minus 1 plus 11. I'm hoping that's starting to like click now. Okay, we want to find the sum. Sum equals n over 2. Uh-oh, we don't know what n is. That means we're going to have to do some work. n over 2 first term plus last term. And what do I do? What do we do when we're missing something? Go to the equation. Okay, now we can use either one. I'm going to use the one at term 0 because it's simpler. And what my goal is to find out which spot number 74 is in, which you can sort of figure out if you don't really need algebra to do this. Like it's not really rocket surgery, this one, but that's fine. Do you see it? See what I'm saying? Okay. What? Yeah, I got this. Yeah. Okay, so I've given you some other scenarios here. These are both going to be very quick. We're just finding the sum only. Um, so I want you guys to tell me what to plug in. Sum equals, what goes first? 14 over 2, 8 plus 151. Okay, the only reason I wanted to do this, I wanted you guys to see that because it's the 14th, you're sure it's the last one because it says there's 14 and this is telling you it's the 14th. So I just wanted you to have that moment of just thinking to yourself, okay, that is the last one because it told me it was the 14th. Okay. What about this one? You're so smart. Okay, so I'm going to start with 25 over 2. I don't know the first term, but guess what? I have the equation, which means that's like a little calculator. I'm done.